Hi everybody. This recording is for our class on Friday, the 17th of September. This is class number 11. As I announced previously, I'm at a strategic retreat with the rest of the college faculty members today. And then Monday and Wednesday of next week, I'm going to be doing an ABET evaluation of another university, and so we can't have a live class meeting. So I'll be providing recorded lecture videos for all three class meetings. This is the first of those three. And then our in-person classes will resume on Friday, the 24th of September. Our homework schedule remains as it's shown on the course schedule. And so the assignment number 4 that you have due on Monday should still be submitted by 11 a.m. And this recorded video has a couple of pretty juicy hints related to the homework assignment. So I'm confident that those will be helpful. I'm also providing you separately a linked video where I go over some best practices for techniques you should follow when you're solving your homework assignment on Excel and just ways to make the information you're sharing more clear to the grader. In today's recorded video, we're going to be addressing some techniques you can use for spreadsheet functions, and so just getting practice on how to use Excel to solve for unknown amounts in the future, and using Excel to solve for unknown interest rates. And then we'll also be taking a look at some more complicated cash flow diagrams and some of the some paper methods for calculating for future values and present values without using the spreadsheet approach. So it's a little bit of both today. As has been the case in a couple of previous occasions, this recorded video largely comes from an earlier semester, and so there may be some incidental references to a time or maybe you'll hear a question from another student. So it's just because some of this lecture has been recycled, but of course the fundamental principles remain the same. And as always, I'll invite you to reach out via email if you've got a question on the assignment. I'd be happy to hear from you. I'll also be accessible on Microsoft Teams if you want to try and give me a call there. Video chat is even better than email in a lot of cases. All right, so that's it. Let's get right into the lecture. On problems 2 and problem 6. And so maybe you've already found a solution to these two problems, and if you have, that's great. You don't necessarily have to change how you did it based on the suggestion that I make. But if you've been struggling, or if you want to try out this suggestion that I'm going to show you as a way to verify what you've done already, then you can do that. So on problem 2, the thing that you do is set up a spreadsheet with the following columns that are shown here: year, the amount that's added, the interest from last year's account balance, and end of year account balance. So let me show that to you, and open up Excel here. All right. All right, so the first one, if you put $100,000 into an account that pays 4.5% annual interest, and you plan to withdraw $5,000 at the end of every year, and you're not making any deposits besides that first $100,000, and how many years until the account is empty? The first thing we do is at time 0, you are adding 100,000, and you haven't earned any interest. You just barely put the money in, so it's 0. And so at the amount that you have at this time is just the 100,000. Okay, in year 1, it says in the problem statement here that you're withdrawing 5,000. So you're not adding anymore, so it would be minus 5,000. Now, what is the interest? Because you're earning 4.5% interest, but you only earn interest on what was in the account last year. For example, if you just barely put in $5,000 today, the bank isn't going to pay you interest on that $5,000. They're going to pay you interest on how much was there during the entire year. And so if we're now at the end of the first year, remember, from 0 to 1 is a 1-year period. And so when we're at 1, we're going to be earning interest on the 100,000 that was in the bank during that entire period. And so the interest is going to be 4.5%, I'll anchor the reference by pressing the F4 button, times 100,000. So $4,500. Here's the thing, is we're taking out more than we earned in interest. So it is the end of year account balance. So at the end of the first year, we have the previous year's balance. So, we had that original 100,000 and we are taking out 5,000, but we're earning interest that year as well. So you can see that it went down at the end of the year because we took out more than we earned in interest. Our balance is a little lower. And so then in the second year, we again take out $5,000, and the interest isn't going to be based on the 100,000. It's going to be based on how much money was in the account during the second year, which means from 1 until 2. That's the second yearly period. And so the interest is 4.5% of this balance. And then the end of year is how much did we have last year plus the amount that was added, which is actually a withdrawal. That's why it's negative. And the interest amount. So things are getting worse and worse. Our account balance is dwindling, and the question is how many years until we empty it out. So basically what I'd like you to submit is a spreadsheet that, not only your answer isn't just, X years. It needs to be the illustration of how you calculated it, like the proof that it's the number of years that you say it is. And so, you can do it by hand or you can do it with Excel, and you should upload your evidence or your proof of that. So that's the hint that I wanted to give you on problem number 2 on the homework. Now on the third problem, the sixth problem, your uncle invests $275,000 today in a business that will return $18,000, then $25,000, and then it increases by $11,000 during each subsequent year. How long until your uncle has collected an amount that is economically equivalent? So this is the table that you set up, and let me bring over a different file that demonstrates this one. All right. So the problem specifies that our interest rate is 5.5%. And so the years we're going to have 0, 1, 2, and so on. So at time 0, it is an investment of $275,000. So that's an outflow. And then the first year, he's receiving $18,000, then $25,000, and then in year 3 it is $25,000 plus $11,000. In year 4 it's going to be the previous amount plus an additional $11,000, and so on. So what we do is we find the PV of the amount, and you've seen this formula several times now. So PV of the interest rate, anchor the reference, the number of years, skipping over the payment field, and the minus of the amount in the future value cell area. So $275,000 in year 0 is already at the present, so the present value function didn't change anything with it. So the cumulative amount at that time is just the negative $275,000. The PV of the second year, I can just drag this down, right? I can just apply that formula, and so we're finding the present value of the amount in the future. So $36,000 3 years in the future is worth an equivalent of $30,658 if it's discounted to time 0. So here's the magic. This is the main thing that you need to see. So cumulative present value of the amount is the last year's amount plus how much came in from this year, taken to the present. So it's going to become less and less negative, and we're saying how long until your uncle has collected an amount that is economically equivalent. That means when is this going to cross over to a positive value? So when he's no longer in the hole, so to speak, when the future revenues that your uncle has received are equivalent to the present investment that was required in order to make this all happen. One of the functions that we're going to use today in our in-class exercise determines the interest rate. And so there's a built-in function called the rate function, and we'll take a look at that with our in-class exercise today. What you put into it is the number of periods, the amount of a payment, and then the present value or the future value that you're trying to find the balance for. Remember, the unknown interest rate, when you're solving for the interest rate, it's the interest rate that brings the inflow and the outflow into equilibrium. Remember the picture of the elephant that's standing on the ball or the balancing rocks? All of those illustrations are meant to remind you that when you're solving for the interest rate, what you're solving for is balance. So you're trying to find equality between the inflows and the outflows. Now, the note that's listed here is that if you have a positive payment, then that means you have to have a negative value for the present value, because Excel is expecting that one of them will be an inflow and the other will be an outflow. So we'll remember that as we do the calculations in the in-class exercise. Oh, one other thing. I'm going to send you a link that explains how to annotate a spreadsheet file, because you're going to be turning in a lot of your work with a spreadsheet file. And so I'm going to send you this link to a YouTube video. You can see here it's only 7 minutes long. And so please review this video, because it just kind of takes you through some of the little notes and ways that you can show your work and make a spreadsheet file easy for the grader to understand what you did. You know, you can't just type in the numbers without any sort of explanation or without identifying the answer to the question that was asked. And so since we're going to be using Excel a lot, I think this brief video will give you some important hints on how to make your submissions maybe a better engineering communication. So expect to see that as an email today. Okay, there is going to be cash flow diagrams that are kind of complicated, like this one, where you're wanting to find the present value, and I'll ask you to do it by hand rather than with Excel. And of course, we could solve this with Excel. It would be pretty easy. You know, we just set up a cash flow table that mirrors the cash flow diagram. And then what we would do is we would find P given F, or in other words, equals PV, because we would want to find the present value for each one of those individual years. But there's a more elegant way to solve a problem if you're doing the table method. And so let me show you a way that we could use the table method to bring all of these amounts to the present. So in one step, what we could do was we'd take this annual series to the present. Now, the general form of an annual series is that the present that it takes the amounts to are going to be 1 year immediately before the first annual amount. And so find P given A is going to take the equivalent of this to year 8. It's not going to go all the way to year 0. You know, the general form of an annual series is that find P will take it to 1 year before the annual series. And so the first step that we'd have to do is find the equivalent amount of a single value in year 8. And the way that you do that is you'd look up the table factor, you'd find P given A for whatever the interest rate is for n equals 3 periods. So now we've got just a single amount at year 8 instead of that annual series. It's the equivalent amount. Now, in the next step, what you do is you take it from year 8 to the present. And so you'd have to do a find P given F. So you'd be discounting a single amount in year 8 to year 0. And so, it was kind of a staged process. The annual series to a present value, and I guess I should do air quotes. It's not really a present value because it's going to be in year 8, but it's a quasi-present value. It's kind of like we're creating a relative time axis where year 8 is really year 0 in the context of the annual series. So the 3 years of 11,000 turns into a certain amount in year 8, and then it goes from year 8 to year 0. So any questions so far about how we moved that annual series in a couple of steps to the real present? So now, what do we have down here below the cash flow diagram axis? These are outflows, and it looks like we have both an annual series and also a gradient. So we're going to need to move both the gradient and the annual series to time 0. And so think about what would the strategy be. The annual series is going to go first to year 3, and then it will go from 3 to 0. And then the same thing is going to be true for the gradient. The gradient, here is our 0G, 1G, 2G, 3G. Okay, so first take the annual series of 500 from years 4 through 7 to year 3. So my strategy is find some amount that's equivalent just to the annual series part of that. Okay, so the first arrow that's down is the annual series amount. So we'd multiply 500 by the factor that you look up in the table, the P/A factor, where I equals whatever the interest rate is in 4 periods. Now the next step is the gradient. And so there's going to be an additional arrow at year 3 that comes from just the gradient part of it. So we would do find P given G for whatever this interest rate is in 4 years. Okay, so then now we have a combined amount at year 3 that has to get to year 0. So we would find P given F, looking up the factor with that, and move it to the present. And so then combine both the inflow and the outflow at year 0 to find out the present value. So that's just kind of an illustration or an animation of how we take a complicated cash flow and go through the process. And so what I'd like you to do, this should look familiar, I just moved things around a little bit, is solve for the present value of this using the table that I've provided in the in-class exercise. It looks like this is going to be 8% interest, and we have the 8% factor table. So I've given you only the factor table for 1, 2, 3, 4, 5, and so on. And that's all you're going to need. So some students might just try and do the brute force approach 1 year at a time. Just keep doing find P given F over and over and over. But I want you to learn that same kind of process that I just illustrated, where first you are going to move things to year 6, and then to the present. And then with this, you'll first move it to year 1 and then to the present. Sometimes, it doesn't matter if you do the inflows first or the outflows first, but in the end, what we're trying to find out is what's the present value of this combined cash flow, take it all to year 0, finding the present value of both the annual series and the gradient. So I'll pause for a moment, give you some time to start crunching the numbers here. We've got plenty of time for you to begin working through this and really give it a good go, and then I will bring the solution up after a few minutes and we'll take a look at it together. In the meantime, if you want to pose questions or type guesses into the chat box or with your microphone, please feel free. Unfortunately, I realized I didn't restart the YouTube recording as I was going through the solution to that first example problem. So I'll just leave it up on the screen for a moment and then bring up the next example problem so that at least the solution gets into the YouTube video. All right, so here is the next one. All right, I'm going to start setting this one up in Excel. So keep working if you already are, but if you're stumped or otherwise just prefer to watch me solve this one, then I'll start doing that on the screen. If your spreadsheet ever does something wonky like starts just to show a bunch of pound symbols, what that means is that there's too many digits for the width of the column. So all you need to do is just drag the column so that it's a little bit wider, and then those pound signs will be replaced by the actual amount. All right, so here is our answer. If you move all of those amounts to the future, let's put a little annotation on here. The sum of the future value amounts. 61,157 and 18 cents. Anybody else get that same amount? I'm hoping I didn't have a typo along the way. I always like it when someone in the class verifies. I'll assume. Good. Oh, I got a star. That's so nice. I love that. Thank you. It really does make your day special, doesn't it? All right. So part B. After solving part A, determine what interest rate would make the future value 100,000. This is interesting. So right now, the future value is 61,000. Well, what the question is saying, play around with the interest rate until you get 100,000. Well, let's just see. If we make some changes to the interest rate, what happens? So 0.08. All right, so it went up and it's headed in the right direction. 0.1 made it even more. So think of it this way, is like, what if you're making more interest? If you're making more interest, then the future value of these amounts is going to be even greater. You know, like if you took these revenues and deposited it into the bank, then if the bank is paying more interest, then the future value increases. So the higher the interest rate, the greater the future value. So rather than me typing this in like a pigeon, what's the smart way to quickly find out if I want to have 100,000 for my total? Anybody remember what that tool is that we use? GoalSeek. Ethan's got it. Good. So GoalSeek is in the Data tab. So click on the ribbon here, Data, What If Analysis, GoalSeek. And what we want to do is set, so that means this should be 100,000. So we're saying we want the total to be 100,000, and then what we're giving the computer permission to change is the location where we have the interest rate entered in. Okay, so the GoalSeek is set this to 100,000 by changing that. So as soon as we click OK, it's going to start running through a bunch of numbers and looking to see. The convergence criteria is it'll stop when it sees 100,000 for cell D22. Okay, so it found it. It found that it's 17.25% would make the future value 100. So we just solved for an unknown interest rate there. We found what interest rate would give us a total amount that we're interested in. Okay, 1 minute remaining. So let's skip over the explain part. That's like a short answer type question. But I want to show you how to use the rate function. And the good thing is it's pretty easy. I'm just going to copy this over to a spreadsheet tab. So here's a cash flow table. And what is the interest rate that brings this into balance? Well, we could do the PV of amount, you know, that method, and then we add it up, and then we would try and find out what's the interest rate that makes the inflows and the outflows equal. That's one way to solve the interest rate. Another is with the interest rate function. And so that is equals rate NPER. Looks like 7. What is the amount of the recurring payment? 7,500, comma, what is the present value? Negative 45,460. Enter. It tells us that the interest rate that would bring balance between that is 4.37%. So we'll use the rate function again in the future as well, but I just wanted to show you that that's a way that you can confirm when you're doing that PV of amount method. If you just use the rate function, then that's another approach.